so that when you people get to Mars and build your colony on Mars, and you've accomplished your first challenge, there'll be other challenges for you to look at. So let me conclude basically by saying Kepler should determine in the next couple of years whether Earth's are common inhabitable zones. What is eta sub Earth? The distributions of planet size and semi-major axis. How many are Mars-sized, Earth-sized, twice Earth-sized? And basically the data is used for the next mission. The next mission that will be flown, almost certainly, will be something that tries to look at the atmospheres of these planets and tell you, does the planet have an atmosphere? What might that composition be? Kepler can never find an Earth-like planet. It can only find Earth-sized planets. An Earth-sized planet could have any temperature. If it's an habitable zone, it's probably got a very nice temperature. But we don't know whether it's got water, and we can't tell whether it's got an atmosphere. So the missions that fly after us need to know, are there lots of Earth-sized planets in the habitable zone? If the answer is yes, you build a coronagraph. It's a very expensive mission, but the National Academy of Sciences has basically indicated that's what you would try. If, on the other hand, there are very few Earth-sized planets, you're going to have to look much further into the galaxy to find them. You will probably build a big interferometer. The first one's very expensive. The interferometer's extremely expensive. Okay? So those are your two choices, and you need the information from Kepler to tell you which way to go. And we certainly determine the fate of Star Trek, because if there are no Earths out there, there'll never be a Star Trek. Thank you. Are there time for questions? Okay. Yes.
For an extended mission, assuming spacecraft healthy at the end of the primary funding phase, it seems the three options are to keep looking at most of the same targets, switch to other targets in the same pointing field of view, or switch to a whole other field of view entirely and start a new set of targets until the spacecraft runs out of communications and distance and consumables. What is the current internal discussion on possible extended missions?
Since you didn't speak at the microphone, I'll repeat the question. Basically what you're asking is, at the end of the mission, what do we do? We're funded for 3.5 years. We have fuel for 10. And so what do we do at the end of that time? And one of the possibilities is to continue looking. The other one is to look at a different group of stars in the field of view, or to move the telescope. The one that we've chosen is to continue to look at the same group of stars. We've chosen the best stars in that field of view, so we're not going to switch stars. Moving a telescope means that we start all over. When we look at the same group of stars, the signal of small planets comes out of the noise. So we see more and more small planets. Those are the guys that are interesting to us. Similarly, as you ask about habitable zone, which is what we're really interested in, the habitable zone of stars hotter than the sun have orbital periods of a couple of years. 2 years, 3 years, so on. That means now, for the first time, we're seeing planets in their habitable zones. So a wider range of stars we explore. So we will not shift the field of view. Robert.
Yeah, just two simple questions. At what general distance are the group of stars that you're looking at? And of the stars that you're looking at, of the candidates, like, is it that we have now candidates of 1% of the stars you're looking at, or 10%, or 10 to the minus 3%? I mean, what is the frequency or probability that a star has a candidate based on their current?
Okay, two questions. One of which is, what is the frequency that we're seeing, and how far away are they? In terms of how far away they are, it's magnitude limited. So if the star is dim, it's close. So we see some stars that are 30 parsecs or something like that, and those are the M dwarfs. They're very cool, small stars. Those are the ones that have habitable zones of the order of a period of a month or two. And those are the ones we're likely to find. If we find planets in the habitable zone, we'd find those first. When we talk about G-dwarfs, we're talking about several hundred parsecs, generally 300 to 500 parsecs. So these are not the stars that you're going to travel to first. They're just telling you how frequent are they. And if you find that most G-dwarfs have such planets, then you can look around. Any of the nearby G-dwarfs would be the ones that you might want to go to. What's the frequency? And the frequency, of course, is heavily biased at this point. We have not corrected for the biases, and the biases are extreme. That is to say, if the orbital plane isn't lined up in your line of sight, you miss most of the planets. So we have to extrapolate by that geometrical factor. We haven't done those things yet. We expect, for the first time, to do that maybe with the announcements this winter, but we haven't done that yet. Okay, you're there on the left with the black hair. Yes, you.
Okay. Was there anything that drove you to selecting the particular field of view that you selected? And the other question I have is, what percentage of the entire sphere, the entire universe, is it that you're looking at?
Well, looking at 1/40th the sky. The reason we chose this group is because, of course, we want to look at the maximum number of stars. This was the richest area that we could look at without looking directly into the plane of the galaxy. The plane of the galaxy is full of giants. Giants basically are a contaminating noise signal for us. We don't want to see those. And the reason we also picked them is we spent 5 years and about that many $1 million looking at 4.3 million stars in that one field of view and measuring the temperature of every one of those stars and getting the size of every one of those stars to say, that is a G-dwarf, that's like the sun, and that one is not. So we picked out just the stars we think are going to be most sun-like. Thank you.